Hi there, we're going to talk about solutions today. Solutions have some math involved in them, so we'll talk about properties of solutions in this section. So here's an example of where water is able to dissolve a solute, which is um, the if I could think about it, the rock that's underneath this, the limestone that's underneath this in Florida, that happens a lot in Florida, where water will dissolve the rock underneath the house or under a street, and it forms a sinkhole, and everything collapses inside. So that's actually water doing something called the solution process. So let's talk about that in this section. So what factors determine if something can dissolve? The factors that we have is what is the solvent made out of, what's the solute, what are the chemical and physical properties, and can one dissolve in the other? So the factors that make something dissolve faster is stirring. So if you are making hot coffee and you want to make a solution of coffee in your sugar, you're going to stir the sugar cube into your coffee and it will dissolve faster. That's called agitation, fancy word in chemistry, agitation. You can have, the hotter the coffee, the better the sugar will dissolve. So that's another factor that will affect how fast it will happen. And if you compare a sugar cube to just a teaspoon of granulated sugar, the granulated sugar will dissolve faster. So those are the three factors that make a solute dissolve faster in a solvent: stirring, temperature, surface area. So this is just showing a cube of sugar will dissolve really slowly compared to if you put granulated pieces of sugar in there. It's going to dissolve a lot better. Hot tea or coffee is a lot easier to dissolve that sugar. And stirring is allowing fresh solvent to get near the solute and dissolve. So in higher temperatures, we have faster moving particles. The atoms and molecules are moving faster, so they can hit into that solute and dissolve the solute faster. And also the particle size, if it's smaller particles, it has a bigger surface area on the outside of it compared to a big cube. You have small pieces, you've broken up that cube into small pieces, there's more surface area for the solvent to attack. So how do we talk about solubility? We can talk about it as something being saturated when you have the maximum amount of solute dissolved in your solvent for that temperature and pressure. Unsaturated is a weaker solution. It doesn't have the maximum amount in there. So saturated, unsaturated. So what happens is you're going to put maybe your sugar or your salt, some salt in water, and the water is going to be attracted to the pluses and minuses. Or if it's a molecular, like sugar, it doesn't have a plus and minus side to it, but it is soluble in water because it has OH groups that are very similar to water shape, so that water can come in and attract these pieces. So the pieces are attracted to the water and pulled out of this crystal. So solubility depends on a lot of things. And we usually express it in grams of solute per 100 grams of solvent, solubility. So some liquids can combine in all ratios, but others cannot. So two liquids are miscible. If you have two liquids together, you're making a mixture. They're miscible if you can do it in all proportions, like 1% or 50-50 or 45-55, whatever proportion, they'll go together. That's called miscible. If two liquids will not come together, they're immiscible. So oil and water is an example of immiscibility. So oil and water are immiscible. Vinegar and oil are immiscible. What determines how much solute you can dissolve in a solvent? What are those factors? So temperature will affect it. Pressure will affect if you're talking about gases going into a liquid. So if you have a soda, for example, it matters how much the soda temperature is, whether you'll have lots of carbon dioxide dissolved or not. So solubility of most solids increases as the temperature of the solvent increases. So that's where we're talking about the hot coffee or hot tea. It'll dissolve more. And most gases are greater in cold water than in hot. So that's why if you leave a soda out on a hot day and it's open, it's going to lose its carbon dioxide carbonation a lot faster because gases don't like to be in hot liquids. So if you go to Yellowstone, I got to go a couple summers ago. It was really pretty. There's lots of solutions. That water there is really a solution. It's got a lot of dissolved minerals in it. When the water evaporates, then the minerals are left. So solubility depends on temperature. Most things will be more soluble in water, but some things are less soluble. There's some solids that are less soluble, but in general, most solids are going to be more soluble in higher temperatures. Supersaturated is when you add more solute than can really be held in that temperature. So this is how we make rock candy. If you've ever had rock candy, you know it's that crystalline sugar on a string or on a little piece of wood. So what they do is they take really hot water, they put lots and lots of sugar in there, they stir it up, agitate it as much as possible, then they slowly let it cool over time, and then those crystals of sugar crystallize out on that string or that piece of small wood. So we allow that supersaturated solution to cool. Sometimes we add a little seed crystal to it to make the crystallization happen on top of the seed crystal. So here's a supersaturated solution before the seed crystal is added. And then we add a little teeny tiny crystal, and then the chemicals in the water attach to that seed crystal and start growing. So you do this a lot in chemistry. We make, especially in organic chemistry, we make crystals to purify the chemical we want to get out of the solution. And there's more and more crystallization going on. So here's some solubility. So sometimes we'll do problems where you have to figure out solubility, or you have to figure out how many grams are in a particular amount of water. So we use this grams of this compound in 100 grams of water. That's how solubility is measured. So pressure doesn't have a little effect on solubility of solids and liquids, but it does strongly affect the solubility of a gas. So that's how they make carbonated beverages. They put the soda in the can, they put a whole bunch of carbon dioxide in there, and then they close up the can, so the pressure over the can is really intense of carbon dioxide. There's a layer of carbon dioxide on the top. So this is Henry's law. I won't use this in this class, but this just shows you how you can figure out how much pressure gas is in the liquid. So I'm not going to do that one with you. So let's try this quiz and see how much you learned about these solutions. Which doesn't influence how fast something dissolves. So it doesn't matter how big the molecule is, it depends on its chemical properties. How do we measure solubility? So it's per 100 grams of the solvent. Usually that's water, but it could be another solvent. Last one. Solubility of a gas is affected by both temperature and pressure. So we'll talk more about solutions in the future. Hope you got something out of this lecture. Talk to you soon. Bye-bye.